Good morning, my dear students. Welcome to this session on cables and suspension bridges. Let us continue from the last session. At last session, we have solved a problem on cables subjected to point loads with a simple example of a single point load case. Now you try this one, which is the similar case of the one which we have solved earlier. So try take this problem and try on your own. This is just a practice problem. Okay. So a light cable is supported at 2 points 20 meters apart. So the distance between the supports, this one and this one, is 20 meters, which are at same level. Cable supports three concentrated loads as shown below. The three concentrated loads 40, 30 and 20 at equidistant. Okay, so the 20 meters is divided equally, so 5 meters each, and the loads are applied. Okay, the deflection at first point is found to be 0.8. So this is equal to 0.8 meters. Calculate the tension in the different segments and total length of the cable. Okay, so this is what you need to solve. Calculate tension in different segments, means TAB, TBC, TCD, TDE. Okay, so if you want to solve T, A, B, B, C, C, D, D, E, inevitably you must solve for HA, HB, and VA, nothing but RAY, and VE, nothing but REY. Okay, so you shall solve all these quantities if you want to solve these four quantities asked for. Okay, so the solution, you just note it. The solution that you should get all these values which are calculated. So VA value should be 50 kilonewton, and now VE should be 40 kilonewtons. It's not B, it is E, vertical reaction at other support E. Okay, so YB is already given, it is 0.8 meters, and YC should be 0.96 meters. This is already given, right? So you don't need to solve this one. YC shall be 0.96 meters. At D it is 0.64 meters. And theta AB 9.09 degree, theta BC 1.833 degree, and CD 3.662 degree, 7.29 degree for the last segment. Okay, these are all the angles with which the cables segments are, the angles that cable segments are making with the horizontal line. Okay, remember that. So TAB segment, AB segment tensile force value is worked out to be 316.49. So when you solve this problem, you should get this value. Similarly, BC segment 312.679 kilonewtons. Similarly, TCD portion, CD segment shall be 313.162 kilonewtons. Similarly, DE segment and the last one, the right hand support, 315.072. So the maximum being 316. Okay, and the total length of the cable, what does it mean? Means the sum of length AB, length BC, length CD, and length DE. Okay, so 20 is the horizontal distance between the two supports A and E. That is not the length of the cable. That is only the span of the cable. Span. Okay. So the span means nothing but the distance between the two supports. Okay. That is what we call span. Right. So length of the cable means what? You shall calculate what is AB length. How do you get it? This is 5 meters, 0 0.8. So you get this value, square root of 5 square plus 0 0.8 whole square. Similarly, so you can get this value because you know YC you know, and this is YB 0 0.8. So YC minus 0 0.8 will give you this value. And anyhow, this is 5 meters horizontal distance between these 2 points, and you can get this value. Similarly, this one. So YC minus YD will give you this value. And anyhow, this is 5 meters. So square root of 5 meters square. And this square, nothing but YC minus YD whole square. So that will give you this value. And anyhow, this is YD and this is 5 meters. The last segment length. So this is square root of this and this. Okay, addition. So likewise, you have to get length of each segment. That will give you can see 20.117 meters. It is more than 20. 20 is the span, and the length of the cable is not the 20. It is more than 20. Okay. So practice this problem. Just like similar problem, this is very similar to this. This is what we have discussed earlier. So the same way, similar lines, we have to practice this one. Okay. Right. So we're going to the next problem. So this is a different case. Till now we have been solving the cables having the supports at same level. Okay. Now it is to talk about the supports at different elevations. What will be the problem? See, if the supports are at same level, if you take moment equation at one joint, one support, the H component of the other support is going to pass through this support. That's why you will be able to solve vertical reactions without knowing H. So VA, VB, you are able to solve without knowing H value, without having the H value. But whereas here, it is impossible to solve VA, VB without H value. Now you can see that if I take moments about A, if the support is here, okay, so HD will pass through this. Only VD will be available, so I can solve for VD. Whereas now you have HD as well as VD, both unknowns, so I can't get the value. So that's the difficulty in this. The supports at different level. Okay. Anyhow, let us see the procedure how we do it. Okay. So determine the tension in each segment of the cable shown in figure below. Also, what is the dimension H? H also is required. And there are some geometry given and some loads given. Okay. So 2 meters, 2 meters, and 1.5. And this is 2 meters here, 2 meters here. Okay, right. So it is very recent question, May 19. Okay. the 7 marks question. So let us see how you try to proceed for this. First, write sigma fx 0. So only two forces horizontal. So HA. So we remove the support A and we'll have two reactions. Okay. So HA, HT is equal to H because no other horizontal force is acting. Now take moments about A. Okay. So what are the unknowns in the equation? H and Vd. Both are unknowns. Vd. So what does this mean? I mean to say if you write sigma MA is equal to 0, you are going to get a function of H comma Vd is equal to 0. Means you will get some equation in terms of H and Vd. Okay. Right. Equilibrium of joint D. No? Once this is over, for equilibrium of joint D, okay, by taking this one, okay, so you can draw free body diagram of joint D where this is H, this is VD, and you see you have to cut this wire, right, for making this free point D. So what I mean to say that this TCD force, okay. Now write. So write H VD in terms of TCD. It is called. Okay. So what does that mean? So in terms of you can write this one. So how do you write that one? You can see that this height is given 2 meters and this is 1.5. It is given. It is available here. This one 1.5. So you can get this angle, right? Some theta, CD or DC, whatever it is, both are same. Okay. So theta, you know. Okay, this I am talking about. Theta I know. Okay. So now what? You have HVD unknowns in one equation. First equation. Now you are trying to create one more equation in terms of H and VD so that you can solve for H and VD. Okay. So TCD cos theta cos theta CD is equal to H, right? Got it? Okay. So another one VD. So TCD sigma Fy0 sin theta CD is equal to VD. Okay. Now what? You have an equation here in terms of H and VD, right? You substitute now in terms of H this one and in terms of VD this one. So now what you have? Only one unknown TCD. Okay. So get TCD by substituting these because theta you know well already calculated. So cos theta value you can write, sin theta value you can write it. So only TCD is the unknown value. So that I'll write TCD. I'll get the value from these calculations. So calculate. So once TCD you get it from this substitution, then substitute TCD here, you get H value. Substitute TCD back here, you get VD value. So H value, VD value from TCD. Okay, so you got tension in CD cable, you got H value, nothing but HA is equal to HD, and you got VD also. Okay, so let us see what to do now. Now sigma Fy0, we get VA. So VA plus VD is equal to some total load. So VA we will get from sigma Fy0. Okay, then what? Again go back to joint A, joint A. Just like the other end is VA value. This is known to you, right? Already solved. H value already solved. Then what do you have? You have to cut this wire, right? So what you have here is TAB, unknown value, TAB, unknown value. And now you see, to get this angle theta or this one, you don't know this height. That is a problem here. Here you know theta, here you don't know theta. So here you don't know height value, the geometry. So that is why these values are to be evaluated first. Then you come to theta, theta AB. Okay. So now you will have sigma fx0, sigma fy0. You will have two unknowns, theta and TAB, two equations. You can get TAB and theta AB can be solved. So once you know theta AB from this equation, okay, so what is theta AB? H, and this is 2. So tan theta AB is equal to H by 2. So you get H value. So that is this one. And for the other segment value, so now you got TAB already, TCD solved. So only BC you want. So either by taking joint B or by taking joint C, you can get TBC value. So this is how it is to be proceeded, right? For how we have to proceed for solution. Okay. Otherwise, what happens if you don't plan the solution like this? You will be solving with so many equations, and you never know which unknown is to be targeted first and which unknown is to be next. So you'll go on solve the equations. So it takes little longer to solve the problem. So if you plan like this, whatever it is, not only like this, you can start from joint A, you can plan something like or otherwise you can start from B or you can start from C. So the options you have to work out and then you have to proceed. So here the only option for us to solve is to start from D only, because if you go to all other giants, there are unknowns more than the equations. You see here there are three unknowns, VA, HA and theta also unknown. So three unknowns with two equations you can't solve. Again giant B, three unknowns, even four unknowns, right? Two forces and two angles, theta AB, theta BC. You can't solve this one. Similarly, this one. So the only option is joint D. That's why we have started at D. We have come back to A. Okay. So this is how you have to proceed, right? So just try this one. How this process we have been following what we have planned. You will get the solution for this. Okay. Similarly, there are some other questions and in October 17, right? So which are very similar in case. So just for the practice, you can just take down these problems and practice on your own, right? So a cable is used to support five equidistant loads over a span of 50 meters. There are five equal and equidistant loads. Find the length of the cable and cross-sectional area if the safe tensile stress is 200 megapascal. The central dip is 4 meters and loads are 5 kilonewtons each. Okay, so try this one. Similarly, the other question, a light cable 24-meter long is supported at two ends at the same level. These supports are 20 meters apart. Cable supports three loads 12, 14, and 16, dividing 20 meters into four equal parts. Find the shape of the string and tension in various portions. Okay, shape in the sense it is asking to find out the YB, YC, YD, something like that. Okay, right? How much is the sag at three different loads? Right. So this is about the cable subjected to point loads. Okay, right. Okay. So practice well with this category. Thank you.